All right, so we're still reviewing 1.1 multiplying and dividing rational numbers. So we just now, even though we've been talking about it, I want to review what a rational number is. So remember, rational numbers are any number that can be written as a ratio in the form a over b, that's a fraction, a over b, where a and b are not 0. And they're different, right? So we're going to write down some examples. So your examples are blank, so copy this down. 6 can be written as 6 over 1. So that's why we prove that even whole numbers are rational numbers, because they can be written as a fraction, 6 over 1. So then we have 5/10. Make sure you write this down. 5/10 can be written as, we can even just do 5 over 10. We're not proving what its exact reducing form is. We just want to know, is it a rational number, because it can be written as a ratio, right? Root word ratio, right here and right here. And so that's all we're trying to prove. All right, so we're going to multiply decimals first. Favorite thing about that, we don't have to line the decimals up. We do have to worry about the decimals after the fact. Always take the one with the most decimals first, 5 and 2/10. You don't have to worry about the signs. Oops, don't know why I'm writing division sign. And we're going to just multiply by 2, like this. 2 times 2, 4. 2 times 5, 10. Remember, when we count how many numbers are behind the decimal, we start at the back, move it over, 10 and 4/10. Now we worry about the signs. They are the same sign, stays positive. There it is. Okay. Now in this case, it doesn't matter which one you put first. I'm going to put 53/100ths first. No, I'm not lining the decimals up. I'm just putting their place values together. 4 times 3, 12. Carry that 1. 4 times 5, 20 plus 1, 21. Carry that 2. 4 times 0, 0 plus 2, 2. Technically, you should move over and do the zeros, but the zeros are just going to add zeros, so I'm not going to do them. But I do have 2 decimals here and 2 decimals here, so that's 4. So I'm going to start from the back. 1, 2, 3, 4. And these blanks get filled with zeros. And I like to put zeros in front of my decimal, so let's practice that as well. It helps clarify where the decimal is. It makes it very clear that it's a decimal and not some weird whole number with zeros in front of it. They are both positive, therefore it stays positive. All right, why don't you pause, try this next one. Pause here, try the next one. Okay, so 3 and 400ths times 1 and 700ths. See, I did not line my decimal up. 7 times 4, 28. If these don't come quickly to you, we need to work on that, but also there is a multiplication chart in your planner that you're welcome to use, and then also a lot of you have it in the back of your comp books. Okay, so either or is a great resource. We're not using calculators yet. 7 times 0, 0 plus 2 is 2, and 7 times 3 is 21. I wrote a 3 and said 20. All right, there we go, 21. We move over. I put an X, that's what I was taught. If you were taught a 0, put that in there. Do it how you like. We're going to go 1 times 4, 4. 1 times 0, 0. 1 times 3, 3. And then we're going to add them together. So 8, 6, 1, 5, 1, 2, and 3. 1, 2, and 3. So 5 and 168 thousandths. Both are negative, so it stays positive, and there's my answer. All right, fractions. So with multiplying fractions, we do not have to find a common denominator. We get to just multiply straight across. 4 times 3, or, well, either way, 4 times 3, 12. 4 times 5, 20. Now, we do have to reduce or simplify. We have to take it down to its lowest terms. So I can divide this one by 4 and this one by 4 to get 3 over 5. Now, I'm going to rewrite the problem real quick. If you know how to cross-reduce, which means reduce first, then multiply, you're welcome to. This has a 4, I can change it to a 1, and this is a 4, I can change it to a 1, because I just reduced these both by 4. Only works if there's 1 in the numerator and 1 in the denominator. So if you know how to cross reduce, go ahead and use it. Then I multiply across, there's the same 3, multiply across, there's the same 5, and you can see they're equal. Do it however way you want. Okay, when we have mixed fractions, we have to change them to improper. You cannot leave them as mixed. So we're going to put 8 over 1, bring that down here. Remember, we multiply here, and we add after here. 3 times 2, 6, plus 2, 8. We get negative 8 over 3. Our denominator stays the same. I still need a negative. Then once we do that, we can multiply across. 8 times 8, 64, but opposite sign, so negative. And then 1 times 3 is 3, and this cannot be reduced, so we just leave it. Do not change it back. Leave it as improper. Okay, so let's pause on the next one. Remember, you have to change those to impropers first. Change them, maybe before you even multiply, check that you've changed them correctly. Then pause again to do the problem. All right, so multiply, add 15, 16, 17, 18, negative 18 over 5, do not forget that negative. Multiply, add 12, 13, don't forget the negative, over 12. Okay, so you can either multiply across, or if you know how to cross reduce, you can. Okay, 18 times 13 is 234. It's positive, because they were both negative, over 60. 5 times 12, 60. I do need to reduce this. Okay, so I know I can reduce it by 2 for sure, because they're both even. Right? If you need to, you can reduce again and again. I'm going to actually reduce this by 6. So, and I'll explain why I do it with 6. So this gets me 39 over 10, and then I'm going to leave it. That's the reduced form. The reason I knew it was 6 is 18 can be divided by 6, and in the denominator, 12 can be divided by 6. If you couldn't catch that right away, you should have divided by 2 and then 3. Okay, so that's what it should have been, divided by 2 and then 3. That was a little trickier, but we do need to make sure we do our best to reduce. All right, dividing with decimals. We are needing to always put the first number in the box. So this is 24 and 35 hundredths divided by 5 tenths. The first number always goes inside the box. So I'm going to write it out, 5 tenths into 24 and 35 hundredths. The outside number needs to become a whole number. We're going to move the decimal, 5. If I move it once here, I only move it once here. They need a match, 1 and 1. So 243 and 5 tenths is what we get. You don't move it all the way over. They have to match, 1 and 1. 5 goes into 24 4 times, it's 20. Subtract 4 left over, bring down my 3. 5 goes into 43 8 times, it's 40. Subtract, bring down my 5. And 5 goes into 35 exactly 7 times, and then I need to make sure I bring my decimal up. They're both positive, so this is 48 and 7 tenths. All right. So, again, first number in the box, second number on the outside. So I'm going to ignore the signs for now. I'm going to move this twice to make it whole. This is twice, this is twice. They match. Outside matches inside. So we get 216. 4 goes into 21 5 times. It's 20. Subtract, bring down the 6. And 4 goes into 16 perfectly 2 times. Now, they are opposite signs. One's positive, one's negative. It needs to be negative 52. Okay, last one. This x just goes here. So 10 and 8/10 divided by 300. So I'm going to set it up for you. And then I'm going to pause. You pause, try to move the decimal, try to divide it out, and then we will see how it goes. Okay, I need the outside number to be whole. 1, 2. 1, 2. They have to match. Fill these with blanks. Or sorry, fill the blanks with zeros. So 3 goes into 10. We should have gotten 3. We get 18, which is perfectly 6. And don't forget to bring down that 0 to make it 0. They are both positive, so my answer is 360 positive. Okay, last one is dividing of fractions. So this is where some of you like to call it skip, flip, multiply. I say multiply by the reciprocal, which is the correct vocabulary, but you can think of it as skip, flip, multiply, but we need to say multiply by the reciprocal. So that means we leave the first one alone, we change this to multiplication, and we flip this. So 3 over 10 becomes 10 over 3. Now we just multiply. 1 times 10 is 10. 5 times 3 is 15. We then make sure we reduce, and we get 2 over 3. When you're multiplying, you don't have to worry about the signs until the very end. So let's do it again. Leave this one alone. Change this to multiplication. Switch these. Keep doing that. 15. Ooh, I can change that. 15 over 4. And then multiply across. That becomes 30 over 12. We can reduce both of these by 3. 10 over 4. Oh, look at that. I can even reduce these by 2. See how I have to make sure? 5 over 2. Okay? One of them was negative, so the whole thing has to be negative. Negative 5 over 2. You do not need to change it. Okay, when we're dividing, just like multiplying, we have to change these to impropers before we can do them. So I'm going to have you pause. I want you to try this one, change them into impropers, then divide them out. So if you change this, you should have gotten negative 13 over 2. Oh, this is supposed to be a division. Change that for me. I don't know where that multiplication sign came in. We're practicing dividing. Divided by 8 and 1 is also 13. That's really nice. 8, 9, 10, 11, 12, 13. So we leave the first one. We change this to multiplication. We flip this one, and we get 8. And you can put the negative here. It can stay at the top. Over 13. So when we are multiplying across, 13 times 8, you should have gotten 104. They're both negative. Honestly, I could have left the negatives off, but they're both negative, so it's going to be positive. And then 2 times 13 is 26. So we can divide this by 2. I know they're both even. So 104 divided by 2 is 52. And 26 divided by 2, we just did that as 13. And then I'm going to let you know you actually can divide both of these by 13 as well. And I know that one's a little tricky, but 52 divided by 13 is actually 4. And because 13 divided by 13 is 1, it's just 4. And I know that's a little trickier, but it's just something. See how we have a 13 in the denominator and a 13 in the numerator? That's how I knew we could divide by 13. Okay, so things to remember. There's a lot, right? Multiplying decimals. Don't line the decimals up. Let's go multiplying fractions. Multiply across. reduce. That's supposed to be a semicolon. Dividing decimals. Move decimal. So outside number, outside number is a whole number. And then dividing fractions. Multiply by reciprocal. Reduce. All right, so here are your independent practice. They must be done for your note takers to have credit on them. So please make sure you finish them all the way up for credit. Until next time.